Hi, we are from Group 3, Section 9, BDA 37601, and we present the lab presentation of Topic 3, which is the bending of beam. And our group member is Muhammad Zarfan Daniel, Muhammad Adri, Muhammad Aziz, Muhammad Baihaki, and Muhammad Faris. My name is Muhammad Zaibin Baharudin, metric number AD100167, and today I present for the theory of this experiment. First, a beam deforms when it is subjected to a loading system or a force couple acting on a plane passing through the axis. Next, when a beam is subjected to a positive bending moment, it develops a concave upward curvature. The material towards the top of the beam is compressed, while the material near the bottom is under tension. The stress is zero at the point where the compressive and tensile zones meet. This is the beam's neutral axis. A simply supported beam is one that is supported by only 2 points and can move horizontally. Here, for the simply supported beam with central point load, the maximum deflection is what is shown in the presentation. And then the simply supported beam subjected to uniform bending moment, its maximum deflection between the supports is there. And next is the formula of the beam compliance.
According to our group observation, for the first test of load and deflection, when the load increased, the deflection is also increased. The largest load, 20 Newton, has the highest deflection, which is 1.05 mm, while the lowest load, 5 Newton, results in the lowest deflection, which is 0.26. The value of deflection of 1.05 mm is also the highest value of the deflection between the three tests. The value of the span remains the same. Next, for the second test of span and deflection, the value of span is the independent variable. As the value of the span increase, the value of this deflection is also increased. The highest value of span, 600 mm, has the highest deflection, which is 0.53. The value of the deflection is the same as the deflection in the first test for 10 Newton load. The lowest value of span, 300 mm, results in the lowest deflection, which is 0.1 mm. Lastly, for the last test of the height and deflection of the test specimen, the value of the deflection decreased as the test specimen dimension increased. The smallest test specimen, which is 4 times 25 mm square, has the highest deflection, which is 0.49. The biggest test specimen, which is 8 times 35 mm square, has the lowest deflection, which is 0.06, and it also the lowest deflection compared to the 3 test deflection. That's all.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zarfan Nabi Ahmad Azri with metric number AD190086, and in this video, I'm going to present about results and also calculation of bending of beam. So, there are 3 results in the experiment, which is the first one, we need to find the relationship between load and deflection. So, this is the results, which is 0.26, 0.53, 0.8 and 1.05. And the second one is, which is the second test, which is the test is we want to find the relationship between span and deflection. So, the span length is 300 mm, 400 mm, 500 mm and 600 mm. This is the span that we use, and the deflection that we got is 0.1. We move on to calculation. For this calculation, we are going to focus more on test 3, which is to calculate the Young modulus of each specimen. So after that, we're going to compare the modulus of elasticity obtained with the theoretical value. So for test 3, we want to, from this deflection, we are going to find our E, which is our Young modulus. So these are the formula that we're going to use. So first, we need to find our I, which is moment of inertia. So this is our calculation for moment of inertia. We get 133.23, 450 and 1066.67. So this is our Young modulus calculation. We just need to substitute the data into the equation. So we use 0.005 kilonewton because and we also use the unit in mm because the result that we're going to get is megapascal. So the first Young modulus, which is 25 times 4 mm, beam dimension, we are going to get 199.30 megapascal. Second one, which is 170.21, and the third one, which is 203.45. So this is our table dimension, moment of inertia, deflection, and Young modulus. So from the modulus of elasticity that we obtain from the theoretical value, we can see that the beam dimension of 25 times 6 mm is the most ductile due to its Young modulus is the lowest. Meanwhile, beam dimension of 25 times 8 mm is the most brittle due to its Young modulus is the highest. So the difference in Young modulus between 4 mm height and 8 mm height is not that much. However, for 6 mm height, there is a lot of difference compared to the others. So that's all for calculation. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adri bin Muhammad Saad. My matrix number CD190296. I'm from Group 3. I will talk about discussion. As you can see, This is graph of deflection vs load. From the graph, we can see the relationship between deflection and load is directly proportional. As the value of load increase, the value of the deflection also increase. The equation of graph is y equal to 5e minus 0.5x plus 4e minus 19. From the equation, we can get any value of deflection from the value of load. When there is no load, there will be no deflection on beam. Second, we can see graph of deflection vs span length. From the graph, we can see a best fit line graph between the plotted line. The graph is a linear trend line and the trend line is positive trend. This proves that as the span length increase, the value of deflection is also increased. The equation of best fit line is y equal to 0.0014x minus 0.0004. When the value of span is 0, the value of deflection will be 0.0004, which is almost approaching 0. Third one, we can see the graph of deflection vs height test of specimen. From the graph of deflection vs height of test specimen, we can see a best fit line which is a negative trend line. Therefore, this proves that as the value of specimen height increase, the value of deflection is also increased. In order to get the least minimum value of deflection, the specimen height must be increased. The equation for this best fit of line is y equal to minus 0.0001x plus 0.0009. Then, with the least specimen height of almost approaching 0, the value of deflection will be 0.0009. The highest deflection will be only be 0.009 for this deflection and height test. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid bin Razmi, metric number AD10080. So next we are going to proceed further with the other part of discussion. So there are some error occurs during the experiment, which includes human error and also dependent errors. This error can change the result of the data and makes the data become invalid. Invalid data cannot be used further in the experiment, which is the calculation and also the discussion part and also the analysis. So as for the solution for the parallax error, we need to position our eye in straight line while adjusting the span length. Next, we also need to reset the deflection device gauge to 0 before subjecting the beam to loads. This is because the deflection of beam needs to start with 0. So before we subject the beam with loads, we need to set the deflection device gauge to 0 and avoid invalid data. Next, we are going further with to discuss about the importance of having several types of beam. As we know, different type of beam works for different types of situation and condition. The beam itself, there is a few common loads can be subjected onto a beam, which includes points load, distributed load, moment, and also rotation. Sometimes there are beams that is subjected to a combination of compression, shear, tension, friction, and torsion. So as an engineer, we need to do an calculation, analysis, and also calculate the safety factor so that the structure that we use in our case beam is safe and functional for the structure. There are a lot of important parameters need to be considered before designing and analyze type of structural beam. These parameters includes cross-sectional area, total depth, thickness of web, moment of inertia, and also the torsional constant. So these are some of the important parameters need to be considered as an engineer to build a safe structural beam. And this structure, so that this structure can be subjected to maximum load and with the appropriate type of support and does not fail and cause a catastrophic failure. So that is the importance of having several type of beam. So at last we have come to the last part of the experiment, which is the conclusion for this experiment. So to conclude, we have successfully conducted an experiment and achieved the objective of the experiment, which is to study the relationship between load, span height, and deflection of the beam placed on two mirrors affected by a concentrated load. So we could really see the relationship of these parameters with the deflection of the beam when it is affected by concentrated load in the result and discussion part of the experiment. And then we have also determined the modulus of elasticity of each specimen by using the formula given in the theory part of the experiment. Next, as for the problem phase, we have not faced any problem during the experiment because the experiment is simple and straightforward. So we have successfully conducted the experiment without any problem occurs during the experiment. As for the recommendation, we recommend that the experiment is repeated 3 times, at least 3 times, to obtain more accurate. We could take the average of the repeated data for the data tabulation and also for the calculation, and we are sure that it will be more accurate. So that is all from us. Thank you very much. Assalamualaikum.